Hello again, folks, in 113. Today we're going to be covering just one section, section 6.4. Let's take a look at the calendar really quickly. And today is September 14th, my grandmother's birthday. So we'll be covering section 6.4. Not in her honor, I don't think she cares. So, anyhow, the packet that I have for you today is an overview diagram that I've made. These are basically the four models that you'll be employing for variation equations when confronted with examples like you see here. I swiped these from the textbook. So we'll go through those. Let me adjust the lights and fire up the camera, and we'll begin. It's okay. A little bit more that way, perhaps. I didn't think I moved it, but I must have, because it's blurry. Sorry, bear with me. You know what I should probably do? Put my glasses on while I do this. Okay. That's all right. All right, I think we got it. I'm gonna leave it forward. I'm sorry. That'll suffice. Okay. Let's begin with this. This is, I said, an overview of the models that you'll be using. All right. The subject is variation equations. That's better. What are variation equations? Well, basically the key phrase here is models. They're sort of a scaffold skeleton model that you will use to apply to specific examples. Right? What they do, more or less as a job, is that these relate one variable, right, to another or several. Right. As you can see, because they're equations, it's one variable on usually the left. Right. It doesn't have to be, but that just makes it a little bit more consistent and easier to apply. One variable on the left, one variable on the left here, one variable on the left, right? And in increasing complexity, you might just have one variable and then something called a proportionality constant. Right? I would guess that this is probably borrowing somewhat from German, because I want to say that constant is spelled with a K rather than C. Right? Don't quote me on that, but that's my best educated guess. Anyhow, when you see K, think C, think constant. As another word, a regular ordinary number that happens to fit here. It makes the units involved cancel where necessary. All right. In this situation, you have one variable related to an inverse relationship. That is, the actual variable is the denominator here. In this situation, you have several variables, right, and proportionality constant. In this case, just two, joint variation. okay? I try to consider or give an example of each of these, all right? Now notice that in the model it's y and x, right? Consistently it's y and x, right? If you look at the diagram that you can print. You could change the variable that is being represented, right? Now I spelled it out here as the circumference formula of the circle, right? I spelled it out, the whole word, circumference, but think a lot of times in geometry that you've seen, right? They don't use the whole word. They use a capital C, right? So y is the thing that is alone on one side here, all right? The proportionality constant is actual pi, right? And then the variable that you're tinkering with, the input, right, or independent variable, is the diameter. So it would be d in this case, a lot of times abbreviated. C equals pi times d, right, for circumference, right? An example of an inverse relationship would be something like the speed formula, average speed, right? Which again, not usually written out as a whole word, abbreviated. So S, is standing in place of y in a situation like this, right? D is distance again, divided by t for time, right? The distance in this scenario would in theory be the proportionality constant. That would be the number that you're relying on, right? And various speeds would be affected by the brevity of time, okay? I really should go clockwise here, right? An example of a joint variation relationship would be if you have two variables, right? Simple interest is a good example of this because it's three things multiplied, right? One could say that the principal, right, which is a fancy way of saying some original amount of money, would be standing in place of the proportionality constant, right? Or maybe the rate, right? It's up for debate, I suppose, which one of these. The rate is the thing that actually would relate one unit to another. So perhaps the rate would be better served as, described as the proportionality constant, and the principal is the x, all right? And time would be the z component here, all right? And in the case of abbreviations, it would be S for simple interest, P for principal, R for rate, right? And T for time, right? PRT. Okay. Lastly, the what came to mind for this more combined variation, all right, where you have in this case three variables, it would be technically, and a proportionality constant. What occurred to me would be the ideal gas law, the kind of thing that you would see maybe in your second semester of chemistry, right? The gas constant would be here, right? The R value, right? And then N is the number of moles of a gas, right? T is temperature in this case, and V would be volume, and P is pressure, right? Anyhow, it's three things that can vary and one thing that is constant, right? Three things that can vary and one thing that is constant, right? So anyhow, these are nice a reference that you will use, all right, when you are trying to answer the word problems that relate, all right? It's kind of a nice tool to have, okay? Just bear in mind, the proportionality constant when you're doing your examples would be the obvious number. Right, so you won't really have to struggle. Sometimes they will ask you to conclude it, rearrange algebraically and figure out what is the proportionality constant rather than have it given to you, right? But it should be the obvious number involved, at least earlier on. Okay, so let's take a look at some examples. All right, remember these names, all right, direct variation, inverse variation, joint, and combined, all right? There is kind of an awkward way, before I move away for a moment, right? There's kind of an awkward way that this particular textbook refers to this without actually drawing the model. Right, so let me point that out first. All right, you will see, all right, how I've written it here. Y is directly proportional to x means y is sitting on one side of equals, and x is the only variable on the opposite side. But an alternative way that they might say is y varies directly as x. It's not wrong to say it that way, but to me, at least as a person who lives around here, all right, it seems kind of vague, all right. Is, as I've been suggesting to you for the past couple of classes, is the equal sign. So if you see y is, you think y equals, right? Directly proportional is referring to these two things, the constant and the actual variable x, being more or less on the same tier, all right? They're on the same level, all right? This means the same thing though. Y varies directly as x, all right? Take that with a grain of salt, all right? Here again, I think this is more intuitive, all right, to say it this way. Y is inversely proportional to x, right? Y is, right? Inversely proportional is implying that these things are not on the same tier. One is below the other, right? You might say, in a situation like this, Y varies inversely as x, right? I don't want to corrupt your opinion, right? To me, it's just a little bit less clear when you say it that way, but that is the way that your book, all right, would probably present this same statement, all right, or this equivalent statement, okay? So just beware of that. Y varies inversely as x means y is inversely proportional to x, all right? And you could figure that out for these two as well, if necessary. Okay? Let's get busy. Take a look at these examples. I did leave the solutions, so you don't have to go hunting for them. But I'm going to try to purposely obscure them as we talk about them. And here's my bootleg paint. I'll clear this. Cooperative markers. Okay, it's a little after 10, so I'm kind of fighting the sunlight. Forgive me. So the coffee here. Okay, I'll read it to you unless you have this printed. The length that a spring will stretch S varies directly with the force, which is also technically weight, F attached to the spring. All right. Write the equation for the length that the spring will stretch as, right, if the constant of proportionality is 0.07, all right? Now, a couple of things. As with all translation from what is English into math speak, all right, sort of look for visual cues. They did give you the variables. You don't have to assume anything yourself. Stretch is S, all right? Force, weight is F, all right? And you have a proportionality constant, which is an actual number of 0.07. They also said this, which is new to us, this section, varies directly. So, of these choices, all right, what you should gravitate towards immediately is this particular model, the least complex of all of them. Y is simply equal to two letters on the opposite side, a constant, all right, and the actual variable. What we're going to have to do is simply change the abbreviations to what is related to the problem. Right, so start with the model. Y is equal to k times x. Right. They want us to write an equation that is for length, specifically stretch. So in place of y, we'll put the letter s. Right. And in place of k, the proportionality constant, we will put the figure 0.07. All right. And in place of x, we're going to use the force of weight. All right. So we would have this essentially. All right. S equals 0.07 times F. Okay. Now, unless they give us any other information, that is either this or this, right, that we're done, right, with this particular problem. That's what they just want you to get used to, right? Changing the abbreviations to make it conducive, right, is another, right? Direct variation in medicine. The recommended dosage D of the antibiotic drug vancomycin, right, is directly proportional to a person's weight. All right. Key phrase here is directly proportional to. So we have this model once again: y equals k times x. All right. And what we'll be substituting is what follows the word is W for weight. So we put a W in place of X in this instance, and dosage in place of Y. Right. Write the variation equation. To write it a little bit more cleanly, it should be this: D is equal to K times W. Now, if they give you some specifics, to determine the recommended dosage in milligrams for Jace, who weighs 128 pounds. Assume the constant of proportionality for the dosage is 18. This is going to be straight up arithmetic in this case, because what is going to fit in here is 18, right? They don't even specify the unit. You can infer that, all right? D is equal to, therefore, 18 times 128 pounds, lb, right? If you're just interested in the numbers purely, this is sufficient, all right? That much, right? And in which case you would take your calculator, all right, and make sure it's not still in scientific notation. Floating decimal, there we go. All right, 18 times 128, and you'll get the actual numerical value you're looking for, all right? 2,304. Now, they did tell you determine the recommended dosage in milligrams, right? Because they haven't given you really any other information, this is not meant to throw you at all. One can assume, right, that this is in fact 2,304 milligrams, and you're done. If you'd like to explore the sort of intricacy here, which is practical, right? I wouldn't say it unless I thought it was important, all right? One would have to assume something. In order for this to be the end result here, milligrams as a unit, the proportionality constant, in other words, what is sitting here, right, which is just quoted to you as being 18 and nothing else, all right, in theory would be the unit conversion factor, which means that in reality it would be 18 milligrams on top of 1 pound, right? How do I know that? Because in order for you to end with milligrams as the unit, and you're multiplying by what is quoted to you as 128 pounds, all right? In order for there to be this cancellation effect, whether you dwell upon it or not, this would be the way it would have to be written, right? This is how it would have to be written, all right? The unit of pound would be cross-canceled being above on the same tier as 18 and this pounds down here, right? It isn't explicitly stated. This is the only reason why I'm mentioning it to you. And it isn't really super imperative. You, at the level of a person who is teaching elementary school, probably won't see this, right? But you can handle it, which is why I'm telling you. And there's, you know, it's something, the intricacy that is worth reflecting upon, right? Because you'll have a greater depth of understanding, all right? I think it's interesting, all right? If you've ever taken a chemistry class, right, part of the way, or a physics class especially, right, how you could tell that you're doing something correct, right, is to examine the units involved, right? Anyhow, we've been discussing this earlier in the semester already, right, where there's a cancellation effect like this. They didn't tell you, again, that 18 was a unit conversion of milligrams to pounds, but you could infer that, right? Because this is the end result. Anyhow, take advantage. Okay. All right. All right. Here's an example number 3. All right. In this case, they want you to probably employ a little bit of algebra, right, to rearrange one of the models to solve for something that's given instead, or not given instead. All right. Suppose W varies directly as the square of Y. Okay, we're dissecting word problems, and we have no fear because we have established techniques for this, right? So don't get scared, all right? Varies directly already implies that we're going to borrow this model, right? Y is equal to K times X. But we may have to tweak it in this particular problem. How come? Because they're talking about this extra feature here, the square of Y. All right. So, don't get thrown. I know that they're using some of the same letters, Y, right? And some that are not the same letters as the model, all right? But what you'll fall back on, all right, to get through it is you'll say, all right, the phrasing of this is what I had mentioned before. They're using the slightly more vague way to talk about direct variation, right? Rather than say Y is directly proportional to X or W is directly proportional to Y, all right? They're using that varies directly as, right? This alternative way of speaking, all right? Anyhow, it's mostly intuitive. This shows up in your face first, right? So in place of Y, we're actually using W in this case. Varies directly equals this model here, right? As the square of Y, right? We're going to leave the proportionality constant, right? But what we're going to do is we're going to change X to Y because that's what's mentioned in this particular problem. And then we're going to remember that they say square, right? Square is one of those things that implies something is raised to an exponent of 2. All right, so it's a little bit higher up. There's this caret symbol, an upward pointing arrow to signify that. So you would fit a 2 in superscript, slightly smaller font, a little bit higher up, attached to Y here. Okay? Now this is basically the model, how it is mutated, right, for this particular purpose, right? Now we're going to answer given some specifics here. If W is 60, right, then in place of W, we're going to stick 60. Right? When Y is 20, all right, find the constant of proportionality. All right? This is still squared, So we have this to work with, all right? This is an equation, all right, which means that in order to solve for k, we're going to have to move stuff around, and we do that via opposite operations. But remember, when you're solving algebraically, i.e. moving over equals, for whatever reason, right? You perform opposite operations. Right. That's what is essentially the process of algebra, right? Before you play the game of algebra, as a prerequisite, always try to simplify each side independently first. Right? That's arithmetic. Right? Arithmetic is the foundational practice of mathematics. Right? Ordinary adding, ordinary subtracting, ordinary multiplying. You do things as they really are. Right? It's only after you've decided that you must shift things around over the equals that you're actually engaging in algebra. Okay? So in this case, what we can do is simplify this chunk here. If it's 20 squared, remember when you square something, it's an instruction to sort of glorified multiplication. All right? Write that base number in two clones, two iterations, and actually multiply them. So what you would get is 60k times 400. All right? Now, if the whole process is to isolate the variable, namely the proportionality constant k, then since I can't combine these any further than I have, right, now I'm going to engage in actual algebra. These things that are pressed together, it is understood that they're being multiplied. So in order to justify moving the 400 from here over to here, it's kind of backwards in this case, right? I'm going to do the opposite of multiplying, which is division. I'm going to move the 400 by dividing by 400 here, strategically to cancel to 1 or simplify to 1, and then do the same thing here to make it legal. All right? Now, you could enter this into your calculator immediately, right, and get the answer, or you could pull some tricks, right, which is a good thing to do. You don't have to, I would never talk a person out of using a calculator, really, but don't let it absolve you of the mental exercise of, mental math, okay? Because that's really what's more important, right? Even more important than the actual answer is the mental exercise, the actual experience of thinking, right? So, you see a pair of zeros here? You could cancel out pairs of zeros, right, that are factored like so, right? Leaving you with a 6 and a 40, right? Then you could apply rules of divisibility. In other words, you could whittle this down before you attempt to convert it to maybe a decimal or something. So they're both divisible by 2, so you could divide each of these by 2. Incidentally, crossing out pairs of zeros is dividing by 10 without really consciously thinking about it, so there's a reason for it, really. All right, 6 divided by 2 is 3, and 40 divided by 2 is 20. All right, now that is a simplified fraction. All right, there's a couple of things you can do at this point. Perhaps more brute force way of doing it is to divide the top thing by the bottom thing, right? And you'll get the decimal, right? Because it happens to be 3 over 20, you could actually upgrade this to something over 100, in which case you would then have the decimal, all right? 20 times 5 would be 100, so 3 times 5 consistently would be 15, which means that this is 0.15 because it's 15 hundredths, all right, THS, all right? 5 sitting in the hundredths place, all right? That would be the effect of dividing 20 divided by, 30 divided by 20, and then dragging down an extra 0 and you get 15 and it terminates. All right. So, for all of our trouble, what is the constant in this case? It would be 0.15. Right? The one thing I want to impress upon you is that if it's true math, right, designed to educate, right, it's not some kind of nonsense or meant to throw you, right, there's always a path to follow, all right? It may not be the most intuitive, but it's there. Take comfort in the fact that there is definitely an answer, all right, for problems like this, right? There's a strategy for it, right? You don't have to feel around in the dark, right? All right, using the constant of, let me clean that up first, that's pretty bad. Okay. Plastic is moving around here. I like to write in blue, but it is rather sticky. It doesn't go away. Okay. The area A of a picture projected onto a movie screen varies directly as the square of the distance d from the projector to the screen. All right. Even without reading anything else. All right. Remember, we have these models that we can refer to. Right. We have a frame of reference that is established. Right. It's saying this much, right? Varies directly as, all right? They're just choosing, again, different variables, right? Area, right? If you want to start with the whole word, go ahead. You know, area varies directly as, right, the square of the distance from the projector. This is a sort of slimmed down version of that. Don't be afraid to reauthor the or edit the word problem given to you, because perhaps the person who wrote it did not write it very clearly. So do yourself and your students a favor and trim it, right? Improve it, right? A varies directly as the square of distance. That's basically what they're saying. So that means A varies directly equals the square of the distance. We had just squared before, so instead of y squared we're going to use d squared. All right. If a projector at a distance of 25 feet projects a picture with an area of 100 square feet, what is the area of the projected picture when the projector is at a distance of 40 feet? Right. What this is asking us to do is basically two things. All right. Plug in the values that are used here. The A value is 25, pardon me, distance. This is the distance of 25 feet and 100 square feet. This is A, this is D, right? And use that to arrive at the proportionality constant. Then answer a second part, all right, for area, all right, when the projector is at a distance of 40, right? So, without calling it part A and part B, all right, I'm going to do what is blue first, all right, to figure out what K is in this model, and then use that value to answer what is in red, right? So, all right, A is equal to K times D squared. Right. If a projector at a distance of 25 feet, I'm going to squeak 25 in here, and I really should put a little parentheses, like a pocket that I'm filling in. This is a good habit, because sometimes you have negative numbers that would also be affected by a square. All right. Projects a picture with an area of 100 square feet, so I'm going to put 100 in here. All right. Could you throw in the units of feet and square feet? Yes, but I'm going to not do that now because I don't want to bog you down, right? But if you did do that, do trust that it would simplify correctly, and then it would tell you technically what the units are of the proportionality constant. All right. Anyhow, we have everything that we need. We have the majority of information, 2 essentially out of 3 parts. So we're going to try to simplify first, which would entail squaring actual 25. And 25 times 25 is 625, I believe. Am I correct? Yes, good. All right, and now I'm going to rearrange this, move this from here to here, over equals, to solve for k. Opposite operation, divide by 625. Cancels here strategically, and you would do the same thing here to balance, right? That means that k is equal to the outcome of this simplified. So you could enter this into your calculator, there's no sin in doing that, but I'm going to try, because I want to set a good example, I'm going to try to do it by engaging in the mental exercises involved, right? This is something that is a nice round number, and this is something that has a 25 attached to it. So if you sort of have a feel for ordinary money, like quarters and a dollar, you might recognize that you could divide this by 25. It's not necessarily the GCF, but it's something that I could whittle down, right? How many quarters are in a dollar, right? 4. How many quarters are in $6.25? It has the same relationship as 25 to 625. Let's see. Well, there would be, all right, 25 goes into 60 twice, all right, which would be 12 left over from 50. And then 25 goes into $1.25 exactly 5 times. So it'd be 4 over 25. Right? Okay. Now, again, you can, if you want to, divide this more or less brute force. That is the top thing by the bottom thing that will convert a fraction to a decimal. Or I'm just going to take advantage. I can then upgrade this to something over 100, and that would more or less tell me what the decimal is without really having to go through the intricacies of dividing. All right, 25 times 4 would be 100, so 4 times 4 is 16, which means that this is 0.16. It's just an alternative trick to getting to the answer. It works only for certain fractions, which is why you can't rely on it 100% of the time. The brute force top divided by bottom to get to a decimal is 100% going to work. All right, this is just something that works in this case, 0.16. All right, now we have a proportionality constant of 0.16. So what I could do is then take the same formula, A is equal to K times D squared, all right, and fill in the missing information, all right? 0.16 is our proportionality constant. What is the area is the question. Given that the projector is at a distance of 40, I would put 40 in here, all right? Because we're just dealing with the would-be right side of this model here, it's purely arithmetic. Just follow the order of operations correctly, which would dictate that you must square before you do the ordinary multiplication. So 40 squared is 160. 1600. 40 times 4, 4 times 4 is 16. With a 0 and a 0 would be 1600, right? So 0.16 times that, right? 16 times 16 is what? 115. I forget offhand, so I'm going to cheat. All right. Let's do 0.16 times 1600. You get 256. The area is equal to 256. Now, since we're talking about an area, remember that an area, whether you included the units or not, all right, the end result ought to be the unit squared, because we're talking about an area, and an area is two-dimensional. So you could say square feet, or you could say feet with a little exponent of 2. Okay? These get progressively more challenging. Let's see if they should just switch gears here. All right. And I finally gotten to inverses. If you look at example 5, sip of water here. Look at example 5. It says the loudness L of a stereo speaker measured in decibels, which is dB unit, varies inversely as the square of the distance d of the listener from the speaker. That sounds like a lot of gobbledygook, but take advantage of the models that we have. In this instance, it says varies inversely. Right? So immediately what we're going to look at in this case is this incarnation of the model. Right? We may have to tweak it, but we have something that is involving this ratio of k over x. Right? Then we'll change the abbreviations. Right? If it says loudness L varies inversely, what that means is that we substitute L with as a y. Right? And if it then goes on to say as the square of the distance d, right, that's the other variable, so we're going to put d squared. Right? It just is it's more subtle when it's suggesting that this is a denominator as opposed to on the usual level. All right? Varies inversely suggests that being down here. Square is exponent of 2, and unique to this problem. All right? If the loudness is 20 decibels, right, when the listener is 6 feet from the speaker, determine the equation that expresses the relationship between loudness and the distance. All right, so what values do we have to substitute now? Let's see. Decibels is the unit for here, this portion of it. You don't really have to put the unit again, but you'll see that it will give you a little added comfort when you're maybe looking for the proportionality constant, if we are in fact doing that, to see that things cancel. All right, it's a way of verifying. All right, when the listener is 6 feet. All right, so you have the proportionality constant, and then 6 feet down here. So this is the actual equation. I'll write it a little bit more cleanly. Loudness is equal to the proportionality constant times the distance squared, over the distance squared. All right, let's rearrange this to figure out k, all right, because we can. Remember, there's no simplifying, well, I should square this first. Take my own advice. Remember, before you move things algebraically, perform ordinary arithmetic. If I'm going to square, all right, it's going to be the exponent of 2 applied to the 6, which means 6 times 6, all right? If I'm just staring at the numbers here for a minute, that means that I have 36 down here, all right? If I want to solve the k, they didn't explicitly say that, but I would do it anyhow, all right? You would then multiply by 36, it's the opposite of dividing, and then do it to the opposite side. So there'll be a cancellation effect by design every single time, leaves you with the thing k that's there, and then that will equal whatever the outcome is on this opposite side. If it's 36 times 2, it would be 72, and then add a 0 to it. So we have a proportionality constant of 720. All right. This would be the full-fledged equation unique to this problem, all right? Whatever the distance is, all right, whatever the loudness is, all right, this is where the proportionality constant would sit in this case, and it would be 720. Now, if I did include the units, again, you don't have to really worry about it too much, all right? The exponent would affect feet here as well, all right? Which means that this would be feet squared, and this would be feet squared, and everything would cancel, and then you'd have decibels, right, still here, and feet squared here, right? That means that the proportionality constant in this case would actually be decibels dot feet squared, right? All right, that's a little extra. Again, you don't really have to stress over it, but the reason that the unit would be included in, say, like a physics class or a chemistry class is because if you have an area down here and you have essentially an area inserted here, they would cancel, right? It would leave you with just decibels, okay? So L is equal to 720 over D squared, okay? Something to think of as an afterthought. All right. Using the proportionality constant, let me erase the mess again. Suppose y varies as x. All right. If again y varies varies inversely as x, that's again telling you to look at this particular model. All right, y equals k dot x, over x, which means you may have to tweak it, but that's what you start with. All right. Now, if they go on to specify that y is equal to 9 when x is 12, you can determine what y is when x is 4. This is again in a very subtle way asking you to figure out what x is first. So borrowing this, right, we would put a 9 in here for y, right, and we would put a 12 in here for x, right. And if in reality it's 9 is equal to k over 12, right, and there's no simplifying that we could do up front, right, then in order to solve for k, we're going to perform the opposite operation. In order to justify moving 12 from where it is at the bottom, I'm going to perform the opposite of division, which is namely multiplication. And if I did that here, my hands are tied. I'm obligated to do it to the opposite side. The 12s would justifiably cancel. Right? You'd be left with k, which is what you're looking for. And then k is equal to the outcome of 12 times 9, which should be 108, whatever the units would be. Right? Then we can answer this other situation. Determine y when x happens to be 4. I'm going to borrow the model, which is that y is equal to k over x. All right? Let's substitute 108 in it now. It's an added step that, again, they don't explicitly state a lot of time. They take it for granted you know whether they should or not. All right? To solve for y now, all right, we would also include a 4 here, right? Which means this is just arithmetic, right? You're really legitimately dividing 108 by 4, right? How many 4s can you squeeze into 10, right? 2, with 2 left over. How many 4s can you fit into 28? Exactly 7. That means that y should be equal to 27. Okay. Next. Here's an example of joint variation where we'll have 2 variables. So going around the clock here, let's point to it before I get to it. All right. We've had a lot of problems with direct variation and now inverse variation. We'll be going to joint variation. So we're going to borrow this model. 2 variables and a constant, just multiplication. So, the area A of a triangle varies jointly as its base B and height h. All right. Jointly, that means look at this. Y is equal to k times x times, is it z in this case? Yes. Okay. The actual input variables are these 2. All right. All right. And we have to tweak this problem. To incorporate the letters variables that they are using. So if its area varies jointly, then in place of y, we're going to stick a. Right. And if it's jointly as its base, b, and h height, you could just put a b in place of h, a b in place of x rather, and an h in place of z. If the area A is 48 square inches, when its base is 12, and its height is 8, determine the area of the triangle whose base is 15 inches and whose height is 20. This is, again, without explicitly stating it, asking you to figure out what this is first. So, if I have this incarnation of the model, A is equal to K times B times H. And what I do is I substitute these figures. 48, I'll put where there's an A. You could put the unit if you want to check that out. All right. The base I'm going to put in place of 12 here, vice versa. And the height I'm going to put 8. All right. In the long run, what you have to be is a little more anal retentive about the units to go, wow, is this going to actually work? This is a unit of inches, and that is a unit of inches, and this area is square inches. So everything is copacetic. But all right, when you're in section 114, all right, the whole chapter of geometry, they kind of bother you about that a little bit more. All right, so we have the majority of information, all right, which is 3 out of 4 parts, which means that we'll simplify what we can, all right, then, which is just arithmetic, and then employ algebra. So what I can actually do, since these are being multiplied, is actually multiply 12 times 8, which means I got 48 is equal to K times 96 it would be. And if I want to now solve for K, I'm going to perform the opposite operation, because now I have to engage in algebra. So the opposite of multiplying is dividing. If I did it here, I must do it here for the sake of balancing. This strategically will cancel. That leaves you with K, right? And then you would have to straighten this out. This should be exactly a half, 48 over 96, because 48 times 2 is 96. All right? If you're wondering, incidentally, well, how do you know? A lot of it comes from experience. If you do your math homework a lot, all right, especially as a math teacher, and you should, all right, you start to remember numbers that you've seen before. I know that sounds weird, but they're like an old familiar friend, right? So anyhow, 48 and 96 are buddies, you know. So you end up with a half, which means that in the decimal style, this would be 0.5 or 50% if you like. All right, now again, borrowing this incarnation of the joint model, we have K times B times H in the parlance, the style of this specific problem. And we know what the constant is. So you could put a fraction here of a half if you like, or you could put 0.5 with 0 or without. All right. Sometimes it's actually beneficial to have the fraction if the numbers that are used here and here are conducive, right? Or you could just punch this in with the calculator, no sin in that. All right, anyhow, I'm going to put in what I can, right, which is that they're telling me the base is 15 inches, so 15 goes in place of B, and 20 in place of H. All right. If I had left this in the style of a fraction, look what would happen. To be able to sort of toggle in your mind this way is very useful, right, in the long run. Right? It spares you from having to always gravitate to your calculator whenever you have a question. It's again, no sin in using your calculator. I don't want to talk you out of doing it. It is a skill, right? But don't do it automatically. Remember, there's sort of mental exercises that you can engage in, and they're important. So. This is a string of fraction-looking style numbers, right? And because it's multiplication, right, you can simplify pretty much in any order that you want. So you might recognize that there's a relationship between this thing down here and this thing up here, even though they're not immediately next to one another, right? As long as one is above the line and the other is below the line, and its factors like this, all right, you can cross-simplify. So 2 and 20 are both even, they're both made of the number 2, therefore they're simplifiable, if you will, divisible by 2. So 2 divided by itself is 1, 20 divided by 2 is 10. That means that if it's just 1s down here, the denominator is totally superfluous. You don't need it anymore. You couldn't put it there, but it's not necessary. And what are you realistically left with? 10 times 15, which is 150. That would be the area, right? If I didn't include the units, right, I could go back and check the intricacies, right? What should happen is that the proportionality constant would automatically cancel out any unnecessary units, right? It's not necessary in this case because it's direct, right? It's inches and inches, so inches times inches would be naturally inches squared. That's a legit area. Okay. All right. Here's combined, which is the sort of creme de la creme. Whole kitchen sink thrown at you now. The load L that a horizontal beam can safely support varies jointly, right, as width W and the square of the depth D, and inversely, right? So jointly and inversely as the length L, right? That's the combo model, right? Which means that we're going to borrow this one that you see here, right? That has an upper tier and a lower tier, right? A numerator and a denominator, essentially. All right. Let's start with the model, right? Y is equal to a constant times an x value, variable times a z variable, all over a w. Eventually what happens when you do this enough, you go, okay, that's the regular ordinary number, these are the inputs. All right, input, 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 and this is an output. It's another way of thinking about it. And that's the constant. Okay. Now, we're going to tweak it again to acclimate to this particular problem. The load varies jointly, right? I know there's a little skipping going around here, but this much is saying y equals blah, 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 all right? Instead of y, we'll call it L, the load, all right? As width W and the square of depth D. So just because W shows up first, don't confuse it with the model, all right? That's a bone of contention, I understand, but remember, all right, we're tweaking this, so we're changing the letters. We're not moving stuff around yet, we're just simply in sort of overlaying, superimposing the conditions onto the model. Just coincidence that it has some of the same letters to begin with, in the wrong places. Width is mentioned first, so I'm going to put that in place of x, all right? Square of the depth D is mentioned second. So I'm going to put a D on top of Z, but remember that it's squares, so it's exponent of 2, right? And inversely as length L. So a lowercase l would be on top of this, superimposed upon this W here, right? Express L in terms of WDL and the constant of proportionality K, all right? To write this a little bit more cleanly, right, this would be what they're asking. They didn't give us any specifics, they just wanted us to sort of, what's the word? Adapt the model to the problem. Number, what is it, 8, right? L equals K times W times D squared all over L, lowercase l. You could, if you feel more comfortable, sort of bunch these things together. I kind of like having them in the factored style. That's the only reason I'm doing that. It's a personal preference. All right, number 9. A different problem. Let's see what we have here. The owners of Henrietta Hots determined their weekly sales of hot dogs, S, which is a weird abbreviation for hot dog, but okay, right? Very directly. So I'm going to just automatically start with that because of the phrase very directly. Right? With their advertising budget A, and then it goes on to say, and inversely, right, with their hot dog price P, right? Which means that although it's not as bad in theory as the last problem, it's still a combo problem. So inversely means that there's going to be another letter here. All right. It varies directly with the first variable, right? And it varies inversely with the second variable. So that's why I didn't include a z in this particular problem, because it's not necessary, right? Now what I should do right off the bat is, again, refine this, adapt it to the unique problem. So they're not using y, they're talking about hot dogs and weirdly calling them S. So in place of y, in this case, I'm going to put a capital S here for hot dogs. Go figure. All right. Their advertising budget is the next thing that is mentioned immediately after the phrase directly in English. So I'm going to put an A here on top of the X. And then inversely with the hot dog price itself, which is P. So since that's mentioned last, after the phrase inversely, I'm going to put a P superimposed upon W. So to write it a little bit more cleanly, I would have this. S is equal to the K constant times A over P. When their advertising budget is $600, and the price of a hot dog is $1.50, they sell 5,600 hot dogs a week. Right? What that is saying, again, not explicitly, unfortunately, sometimes the instructions are intentionally vague, right, is that you can substitute these values and figure out what K is. Right? Write a variation equation expressing this, right, which you kind of jumped the gun and did anyhow. Include the value of constant of proportionality. All right, to answer that, I'm going to do exactly what I just suggested, which is I'm going to put in their specifics. Advertising budget is $600 here, and the price of the hot dog is $1.50 here, and the number of dogs is 5,600. Okay, so you can try to simplify this first. It's probably the best course of action. Or in theory, you can sort of jump the gun and go directly to the algebra, but because it's factors. All right, but I would try to simplify it if I could. All right, borrow some technique here. If we have 5,600 is equal to K times 600 over 150, that's a factor X, and this is a decimal point. Being that this is in factored form like so, you can, if you want to, sort of separate this part out and then whittle that down. Maybe it's unnecessary in this case. It might be more trouble than it's worth adjusting the decimal point in both cases and then crossing out a zero. So the minutia would basically be this, right? I can tell you from experience. I don't want to overcomplicate something, but if it was, I'm just looking at this much of it, right? What I would do instinctively, from having been doing that a lot and brainwashing myself, is, well, that's a whole number and this is not. So you have to get them to be on the same level here in terms of their style. So make them both whole numbers, all right? In order to accomplish that for something that has two decimal places, you would need to scoot this over two spaces, all right? Legally speaking, that would be times 100, all right? You can get away with murder, all right, changing the appearance of something as long as you're consistent. So if in theory, that's what it would take to get this to be a whole number 150 down here, I would be obligated, I would have to do the exact same thing to the top, which is kind of a nuisance because now I'm getting this number much larger. Instead of 600, it would be 60,000, right? How come? Because times 100 would also move a decimal over two spaces and add two extra zeros. So I'd have 4 total. Then at that point, what I would do is cross out a pair of zeros. That's like now dividing each of these things by 100. And the actual relationship would be the same as 6,000 over 15. All right? I happen to know from, again, dealing with a lot of problems over the course of many years, all right, recognize that 15 and 60 work well. They come from time, right? A quarter of an hour is 15 minutes. So, and 60 would be the whole hour. You could divide each of these at this point by 15, in which case the bottom would be 1, and the top would be 4 with 2 extra zeros. Right. Which means if this ends up basically being 400 on top, then in order to justify moving it from here over to here to solve for x, I would divide by 400 and divide by 400, right? And the effect would be cross out a pair of zeros, cross out another pair of zeros, divide 56 by 4, and you should get a nice number. 4 goes into 56 once, with 1 left over, would be exactly 14. So k would be equal to 14. All right? A less intricate way of doing this, so you're not mad, would be to do this more or less piecemeal, which is to, all right, I'm not going to deal with the arithmetic because I feel a little uncomfortable. All right? What I could do is move each of these parts, the 600 and the 150, 1.5, one at a time, according to opposite operations. So if you wanted to move the 150 multiplied by 150 here, these would cancel, and then you would have the same thing over here. All right? Then divide by 600 as an afterthought, these would cancel, and then plop it underneath here. All right? Now your instinct again might be, well, I'll just do 150 times 5600 and then divide by 600. That's not wrong, but if you leave it in this quasi-factored form here, well, it is technically factored, you could take advantage of the same sort of process, all right? As long as they're factors like this, all right, they have a common denominator, you could cross out these zeros. All right. You can simplify what's left over, the 6 and the 56 by 2. All right, whatever works. There's lots of different ways to do it, really. All right. It occurs to me that you could actually divide these two and get this to be 1 down here, 6 divided by 6, and then the actual division of 1.5 divided by 6 would be, let's see, 6 goes into this twice, which is 12. The difference would be 3, it would be 25. All right. Then you have 0.25 times 56, which is crummy. All right. But 0.25, which is left over up here from doing that division, is 1/4 times the 56 that's left over. That's the same thing as this. All right. So no matter what, you're going to get 56 divided by 4. All right. Whether you use a calculator or not, and you're going to get 14. Okay. All right, so what was the whole point of this? We have the k, all right, and the k is 14. All right. So the adapted version of this is s is equal to 14 times a over p. All right, and then we can answer the second portion of this. B. Determine the expected sales if the advertising budget is $800 and the hot dog price is $1.75. All right. We've done the hard part. We've figured out all the parts, including the proportionality constant unique to this problem. So now we can, at will, right, insert specific figures here. So if I'll put this maybe in green, right? If S is equal to 14 times the advertising budget over the price, right? And we know specifically that they want to calculate the expected sales with an advertising budget of $800, right, and a price of $1.75, you have everything you need now, right? What you should do, since you would just be simplifying this, you'd be performing arithmetic, therefore the order of operations. Straighten out the top, right? Divide by the bottom is probably the easiest thing to do, right? And also conforming to the rules. So 14 times 800 divided by 1.75. You should get 6,400 dogs, right? They become so abundant they'd be our currency.
That's from an old skit on Saturday Night Live.
6,400 hot dogs. Last one. A varies jointly as B and C, and inversely as the square of D. Alright, so back to worst case scenario where you have basically 5 letters, 4 actual variables, 1 constant. Alright, so if they mention jointly, we have this incarnation of a model to begin with, the sort of linear model here, k times x times z, and inversely, as the square of d, alright, that means that we would borrow from this shape. Now we're going to just swap out the unique letters to this problem. Alright, so if it's A written in front varies jointly, then in place of Y we would put an A. Right? If what follows it is B and C, you'd put a B and a C here respectively. You always skip over the constant. Right? And as the square of D inversely, it follows the phrase inversely, that means that D would be down here, and it would also be an exponent of 2. Right? So that means we have this to start with, k is equal to b dot c over d squared. If a is 1, when b is 9, c is 4, and d is 6, find a when b is 8, c is 12, and d is 5. Alright, this is another situation where, without explicitly stating it, we'd have to find this first. So we're going to play their game of inserting numbers where we can, and that will go here and here respectively, and 4 and 6. Simplify and then solve specifically for the constant, right? Then after the fact, go back to this model with the constant inputted and any of the other specifics to find A. So what we end up having here is we have technically a 36 on top and a 36 underneath it, which means that we have 1 is equal to k times 36 over 36, and that would immediately simplify down to just k is equal to 1. So not too bad, right? Then we would, the fact of the matter is if you put a 1 in here, it's not going to change anything, all right? 1 times anything is an identity, all right? So now if we insert the specifics, B8, that looks kind of the same thing anyway, how appropriate. 12 is C, and D is 5, all right? Let's simplify, and we'll answer the question for A. All right. As long as you do the top independently of the bottom, all right, and then divide dead last for things that are rational expressions like this, that is, they have a top and a bottom, all right, everything is fine, all right. If I were really going to be rigid and follow the order of operations, which is a good habit, all right, technically my eyes would gravitate towards 5 squared because it's the exponent. So anyhow, that would be 25 down here, and there's nothing else I could do. And then the stuff up here would be 8 times 12 times 1, which would be 96, right? Now you could, again, try to pull tricks if it's possible to simplify it down to a smaller fraction of the same overall relationship, or just go straight for your calculator. Again, I wouldn't get mad at you, right? So let's see. I think you're gonna get stuck with a crummy decimal, so what'd you get? Yep. All right, 3.84, right, is what the A would be. 3.84. Cool. Right. All right. Let me put that there. And I think we have finished with that. Good. Right. So let me just remind you what to do. I'll turn off this projector and lighten up the space here. In theory, by this point, you have established a MyLab account through Canvas. You want to do that now just because that's how you do your homework. And that counts for your 50% of your grade, so please do not do your homework. Right? But where you should be is here. Right? For homework, right? Assuming you have a MyLab account, right? Do section 6.4, right? This with all of them from this sort of cluster, right? This will be due by, let's see, Wednesday evening next week, so 9/22, right? Right. If you haven't had an account to this point, right, just realize that there's a pile of assignments that you have to do. Right. What has occurred to this point is a prerequisite, right, which is required. Right. So it's a prerequisite for problem solving. Section 1.1 and 1.2 from the first day, in addition to that. Section 1.3 and 6.3, which has 2 parts, part 1 and 2. And now we have section 6.4, right? Anyhow, this is why I keep saying, all right, you want to get this as soon as possible because it's starting to pile up now, okay? So don't go any longer, all right? If you don't have an account, I just put an X in your Canvas. It's not really hurting you or affecting your grade, but obviously if you don't have an account, then you can't do the things that do affect your grade. So don't wait any longer, right? You don't want to get stuck doing all of this on that evening, okay? So thank you guys for sticking with me. I will see you again on Thursday. Be careful out there.